Okay, so that's how we'll always find the x-intercepts. If we're given a graph, we just look, where does that graph cross the x-axis? And then that tells us our x-intercepts. And then we have the y-intercept. So remember, the y-intercept is where the graph crosses the y-axis. So we know that our y-intercept is -8 because that's where it crosses our y-axis. And then this point, it's either the lowest point of the parabola or the highest point of the parabola. We call that the vertex. So it's the highest. If it's the highest, it's called the maximum. If it's the lowest, it's called the minimum. And then we have what's called the axis of symmetry. It's a line that cuts the parabola in half, where this half is a reflection of this half, and it goes through the middle of the parabola, which the vertex is always right in the middle. So it's always going to go through the vertex. And that is our axis of symmetry. So in this case, the axis of symmetry, since it's going through the x-axis, it's at x equals, it's going through at 1. And this is the vertical line that goes through the vertex. And then once you're finished copying these down, go ahead and open up your workbook to page 102. And then keep your notes handy because it'll help us on the assignment. So we need to label the zeros, which are the x-intercepts, label the y-intercept, the vertex, and the axis of symmetry. So let's start with the zeros. Remember, that just means the x-intercepts. So it's literally where the graph intercepts the x. So here's our x-axis. It hits right here and right here. So those are the x-intercepts. Then we have our y-axis right here. And so we go down the y to see where a graph crosses the y. And it crosses right here. That is our y-intercept. The vertex is the highest or the lowest point. So in this case, it's going to be the lowest point right here. Here's our vertex. And in this case, it's the lowest. So this is our minimum. So the lowest point that our parabola is going to go. And then our axis of symmetry is the vertical line that goes through the vertex. And so that right there is the axis of symmetry. Okay, I'm going to do one more and then I'm going to give you guys problems. So we'll start with the zeros, which are the x-intercepts. So again, we go to the x-axis. Look where our graph crosses the x-axis. Those 2 points right there are the x-intercepts, or the solutions, or the roots. They all mean the same thing. There's just a lot of different names. Then the y-intercept, we look to see where does it cross the y-axis. It's up here this time. What parabola crosses right here, our y-axis, so that is the y-intercept. And then the vertex is the lowest point or the highest point. In this case, it's the lowest, so it's the minimum. And then sketch the axis of symmetry. Okay, so then Bella, can you do number 3? Dakota, number 4. Kaleni, number 5. Lenice, number 6. Savannah, number 7. Solomon, number 8. And Tiana, number 9. And I'll do number 10.
I do have one question.
Uh-huh.
To find the y-intercept, is it just whatever line touches finally the y line?
Yep, it's wherever the parabola goes through the y-axis. So
Okay.
you just run your finger down the y-axis until it touches the parabola, and that's your y-intercept.
Okay.
Okay, so let's start going over them because they're pretty quick. Okay, so Bella is not feeling well, so she's going to send it to me in the chat. Go ahead, Bella, whenever you're ready. So I'll point to the points and then you can tell me what they are. So let's start down here and then we'll work our way up. So what would this point be, Bella? The vertex, and it's a minimum. Very good. And then this point over here would be the y-intercept. Excellent. And then what about these points up here? The zeros are the x-intercept. Perfect. And then we'll just sketch our axis of symmetry. It goes right through the vertex. Good, thank you, Bella. Okay, and then some people left, so our order might be funny now. Dakota, did you have number 4?
Yes.
Okay, so what
It,
were these, Dakota?
those are going to be your X.
Good. And then what about this one up here?
Your Y.
Good. And then this one down here?
Your vertex minimum.
Excellent. And then our axis of symmetry is just the line through the vertex. Okay. Kaleni, did you have number 5?
Yes.
Okay. So what are these 2 points?
Those are the x-intercept.
Excellent. What about this one up here?
The y-intercept.
Excellent. And then this one down here.
The vertex minimum.
Very good. Excuse me. Great. Thank you, Kaleni. And then our axis of symmetry goes right through our vertex. Very good. Excuse me. All right. Thank you, Kaleni. And then, Savannah, did you have number 6?
I had number 7.
Excuse me. Okay, I think our person that had number 6 left, so I'll go ahead and do it. Let's see. So this one doesn't cross the x-axis. So there's no x-intercepts. This down here would be our vertex, and it's the lowest point, so it'd be our minimum. And then this one right here is where it crosses our y-axis, so that would be our y-intercept. And again, there were no x-intercepts, so we just need our axis of symmetry right through the vertex. Okay, and then Savannah, number 7, what are these 2 points?
Those are the x-axis.
The x-intercepts, very good. And then what about this one up here?
That one's the y-intercept.
Very good. And this one down here?
And then that's the minimum vertex.
Excellent. The minimum, excellent. And so we sketch our axis of symmetry through our
And then
vertex.
the axis of symmetry.
Excellent. Thank you, Savannah. Solomon, number 8. What are these 2 points?
The X.
The x-intercepts, excellent. What about this point down here?
Y.
The y-intercept, very good. And what about this point up here?
The vertex.
Excellent. And in this case, is the vertex the minimum or the maximum?
Maximum.
Yep. That's the highest our parabola goes, so it is the maximum. Okay, and Tiana, number 9. What are these 2 points right here?
The x-intercept,
Very good. And then this one right here.
the y-intercept,
Very good. And up here,
the 0.
it's the what?
The 0.
The x-intercepts, these are actually the zeros. This one is the vertex. So it's the highest.
Vertex.
Yep, it's the highest point. Again, since our parabola is opening down, so it's a maximum.
We also had to do the
Oh yes, and then the axis of symmetry.
axis of symmetry.
Yep, through the vertex. And I forgot to do it here on number 8. Very good, thank you. Okay, and then for number 10, here's our vertex. And again, it's opening down. That's the highest point. So that is our maximum. These two are crossing the x-axis. So those are x-intercepts. Doesn't look like it crosses the y. There's no, we can't see it at least. So we can't label the y-intercept. So we'll just do our axis of symmetry through the middle. Okay, so that was the Monday and Tuesday work. Any questions? Alrighty, so next is the quadratic formula error analysis. So you have the notes. It probably would help to have these. So we'll just review the steps really quickly. So we have our quadratic formula. First, we list A, B, and C. We write the quadratic formula. We plug in A, B, and C, solve for X. So here, remember, we always need it to equal 0. So the first thing it looks like they did was they moved this 2x squared to this side. So then 0 on this side, which is what we need to use quadratic formula. So we have 2x squared plus 17x minus 9. And then A is 2, B is 17, C is -9. That all looks good. Let's write our quadratic formula up here so that we can check their work. So then we have -b. So they did -b plus or minus the square root of b squared. That looks good. Minus 4 times a, which is 2. Oh, times c, which is -9. All over 2a. 2 times a, 2 times 2. So it looks like the first mistake is they plugged in c wrong. They put +9 when it was supposed to be -9. So then let's go through and simplify. We get -17 plus or minus 17 squared, which is 289. And then they got -72. But if we multiply -4 times 2, that's -8. And then -8 times a -9 would make this a +72. So see, once you make a mistake in this first step, your answer is going to be wrong. Everything after that's going to be wrong. And then divided by 4. So we can show the correct work over here and get the correct answer. So this should be -17 plus or minus the square root of 17 squared minus 4 times A times C all over 2 times A. And then we get negative 17 plus or minus the square root of 289. But we said this should be plus 72 because now we have a negative times a positive times a negative divided by 4. So then let's see, 289 plus 72 is 361. And so this is the correct solution. Okay, go ahead and look at number 2. So let's just look at this first step. So again, we need to get it equal to 0. So we do need to subtract 24 from both sides so that we get equals 0. So x squared minus 5x minus 24 equals 0. Okay, that's good. So now go ahead and check their A, B, and C, and then if they plugged in correctly. And when you find the mistake, send it to me in the chat. Okay, so I've got some responses from some people, and yes, it looks like our negative b, they forgot to put the negative 5. So b is negative 5, but remember it's negative b, so that's why we always use parentheses. So it should be, this should be a negative and then parentheses negative 5. So for negative b, they put b. So what should it be? It should be a negative times a negative 5, which is positive 5. Well, we can write, let's write out all the steps. So it should be negative 5 plus or minus the square root of b squared, which is negative 5 squared. So they did it right here, just this first one. So minus 4 times a, which is 1, times c, which is negative 24, all over 2a, which is 1. And then we'll simplify it. So now this is a positive 5. So that's where they messed up. Plus or minus the square root of negative 5 squared, which is 25. Negative 4 times 1 is negative 4 times negative 24 is positive 96. Divided by 2. So this would be 5 plus or minus the square root of 121 divided by 2. which we actually can simplify this because we know the square root of 121, that's a perfect square. So we get 5 plus 11 divided by 2, and then 5 minus 11 divided by 2. So we get 16 divided by 2, which is 8. So it'd be 8, 0. And then we get -6 divided by 2, which is -3. So our other one would be -3, 0. All right, any questions on these two problems?
Could you scooch it over a little bit more?
This way?
Yeah, that'd be perfect. Thank you.
Can you guys see the chat and like on your end, Savannah?
There's nothing in the chat, no.
Okay, it's not blocking because my chat was kind of open, is covering part of it, but
Oh, no, it isn't
okay.
showing.
Okay, thanks.
Can you scoot it up a bit? A little bit.
This way?
Yes.
Sure. Okay, did everyone get it? Anyone need more time? Okay. So let's flip. To our application. Okay, so we have to read the graph and answer the questions. So using the graph at the right, it shows the height, h in feet, of a small rocket, t seconds after it is launched. The path of the rocket is given by the equation, the height equals -16t squared plus 128t. So how long is the rocket in the air? So can you guys send me? So look at it. We have our time in seconds, and then we have our height of the rocket. So looking at the graph, how long is the rocket in the air? Sorry, Tiana, I just saw your message. I'll put it back up for you before we leave. No one? So go ahead and send me, how long is the rocket in the air? So look at the graph. So it starts on the ground, it goes up, 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 and then it reaches its maximum height, and then it starts coming down. So total, how long is it in the air? Yes, thank you. So about 8 seconds. We can just say 8 seconds. And then what is the greatest height the rocket reaches? So the maximum height, what does it get to? How high in the sky does it go? Yeah, about 260 feet. Very good. Okay, and then about how high is the rocket after 1 second? So we go where the time is 1 second and the height looks like it's right about 100 feet. Good. Okay, now after 2 seconds, about how high is the rocket? 2 seconds. About, yeah, pretty close. A little bit below, less than 200, but we can just round about 200. And yeah, like 190-ish. And is it going up or is it going down?
It's going up.
Going up. Good, Dakota. Okay, what about after 6 seconds? How high is the rocket?
Yeah. 190 again.
Yep, back down to about 190. And now is it going up or down?
Down.
Now it's coming back down. Right, good. Okay, so do you think the rocket is traveling faster from 0 to 1 second or from 3 to 4 seconds? Explain your answer.
I think that it's traveling faster at 0 to 1.
Okay.
Because if you look at 3 to 4 at that pace, it's it's not as a far distance as from 0 to 1.
Yep, you're exactly right. Yeah, if you look from 0 to 1, it's pretty steep, your line. It's going up really quickly. You can tell in a short amount of time, right? Whereas from 3 to 4 is from here to here. So your line gets a lot less steep. That means you're going much slower. Very good. Means you're going a greater distance in a short amount of time. All right. Next, we have a ball is thrown in the air. The path of the ball is represented by the equation. The height equals -t squared plus 8t. Graph the equation over the interval 0 is less than or equal to t, or 0 is less than or equal to t is less than or equal to 8 on the accompanying grid. Okay, so to graph this, we need to, it looks like, factor with 2 boxes. So we have -t squared plus 8t. So we have -1 times t and 8 times t. So we have t, and then we have -t plus 8. So t times -t plus 8 has to equal 0. So remember, we set them each equal to 0, which means t equals 0. The -t plus 8 equals 0. So we subtract 8. Negative t equals -8. So we have to divide by -1. And so t equals 8. So those are our x-intercepts. And then the y-intercept is going to be at 0, because remember, the y-intercept is always c. It's the one without a t. Let's see. What is so let's graph that. So we can graph it at 0, 0, and then 1, 2, 3, 4, 5, 6, 7, 8. And it looks like we're going to need some more points. So we're going to have to plug in at 1 second, at 2 seconds. We don't really have enough space here. So let's create a table. So we want to know the height at each second. So after 1 second, 2 seconds, 3, 4, 5, 6, and 7. So we know that the height equals the negative t squared plus 8t. And so we're just going to plug in t. And we're going to use our how we learned to create a table. So let's see. We have negative 1 squared plus 8 times 1. So we have 1 squared, which is 1, and then that's multiplied by negative. So negative 1 plus 8, which is 7. So our point we're going to graph is 1, 7. And then after 2 seconds, let's figure out how high it will be. So negative 2 squared plus 8 times 2. 2 squared is 4 times a negative would make that negative 4 plus 8 times 2, which is 16. So that would equal 12. So our next point would be 212. So after 2 seconds, the height is 12. Let's see after 3 seconds. So 3 squared is 9, multiply that by negative, that's negative 9, plus 24, which is 15. So after 3 seconds, the height would be 15. Plug in 4. Negative 16 plus 32, which would be 16. So after 4 seconds, it's at 16.
Could you slow down a little bit?
Yep. I'll give you a second to get caught up. So we're just, remember, this is what we did on the creating a table to graph a quadratic. So we're just plugging in the t's into our formula.
As we're writing them, we're marking the graph, right? Or not yet?
Yeah, you can. You can as you go. Or I would just do it all once we've finished the table.
Okay. Yeah, 'cause I didn't know if you want us to do it at the same time.
You can. You feel free to. I know, sorry, there's not enough space here. That's why I was thinking we could just factor, but you really need a table to answer the questions. so now let's see after 5 seconds. So we're just going to plug in 5 now. So 5 squared is 25. So that's negative 25 plus 40, which is 15. So after 5 seconds, the height is 15. Then 6. So negative 36 plus 48, which is 12. So after 6 seconds, it'll be 12. And then 7. Plug in our 7. Negative 49 plus 56, which is 7. A lot of work. Okay, so then we need to label our graph. So we can go by ones, it looks like, because it just needs to go up to 16, hopefully. So I'm going to do every other one. 2, 4, 6, 8, 10, 12, 14, 16 meters. And so after 1 second, we said the height is 7. So we're going to go to 1, 7. Then after 2 seconds, it was at 12. So 2, 12. And then 3, after 3 seconds, the height was 15 meters. So we go to 3, 15. And then 4, 16. And then 5, 15. 6, 12. And after 7, it's at 7 meters. There's our parabola. Okay. Any questions on our graph? Okay, I'll give you a second to finish plotting the points because I probably didn't give you enough time.
I have a question about the graphs. For the graph, the point you dotted between 6 and 8.
This between the 6 and 8?
Yes.
Uh-huh.
Wouldn't we have never mind, I forgot my question.
So I just did it there because that's 7. So just so it wasn't so like squishy how it was down here, I just numbered by 2s. So this line between the 6 and the 8 was just the 7. So that's why we have the point 17. That's why I plotted it right in between the 6 and the 8, because that's 7. So at 17 and then at 7, 7.
Okay, thank you.
You're welcome. Okay, so now that we have our whole graph, our complete graph, now we can answer these questions. So what is the maximum height of the ball? What's the highest the ball gets?
16.
16. Very good. 16 meters. That's our vertex. That's the top, our maximum height. Okay. I think it means how long, how long is the ball above 7 meters? So when does it get
4 minutes. It's up there for a minute.
At 7, so it means above 7 meters though. So anything above. So it's above 7 meters right here, starting at 1 second, right? And then it doesn't drop below until 7 seconds. So that would mean for 6 seconds. It's above 7. So it's above all the way from here.
That, to me, that makes no sense. That question.
So yeah, it's just asking how long is the ball above 7 meters. So you just look at your graph from where it gets to 7 meters. And then it's above 7 meters all this time until it comes back down here. Here's that 7 again, which is at 7 seconds. So from 1 second to 7 seconds, it's above 7 meters because then it goes from 7 to 8 to 9 to 10, all the way up to 16, and then back down. Okay, so at what time does the ball hit the ground?
Minute.
Well, what was that, Dakota? It cut out.
I said 8 minutes.
Yep, or I think these are seconds. It doesn't say, but I'm assuming yes. And Bella sent that too. Very good. 8 seconds. And then what is the height of the ball after 2 seconds? So at 2 seconds, it is 12 meters. Very good, Bella. So you can look at your graph. We could also look at our table. At 2, it was 12. So it's 12 meters. Okay, it's 11 o'clock. So I know some of you need to go. If you received the email for the targeted tutoring, so this is fine for the quadratics. I think we did enough application today. You don't have to worry about 106. So the only other thing you'll have to do for this week is the problem solving task. So unfortunately, we ran out of time and didn't get to this. So you just have to do the problem solving task. And then make sure to finish your journal and turn in your journal as well. And if you need to do the Unit 9 study guide and test, please stay on. We'll get started on that right now.
I got the target email, but I also have another Zoom.
Okay, so then Solomon, just make sure that you go on and do it then, okay?
Okay.
So I think you had done the test. I think you were just missing the study guide. So it's just one of the multiple choice study guides on Canvas. So just make sure to do that Unit 9 one.
I didn't get the email, but I do have one question.
Oh, sure.
I didn't get that.
It was for the, let me look at it right now. One second. Okay. It was for the unit. Okay, there's 2 questions. For Unit 7 test, I got 43.75 out of 100. Is that okay to leave like that, or do I need to?
You're fine.
It's out of
Like, you
50.
have- Yeah, that's a B. That's a good B. So that's fine. Yeah,
Okay.
that's good.
Okay. And then my next find it. One second. It was for the it's for the checkpoint. I needed help on it for Friday's checkpoint.
Okay.
Like whole 20 questions. I didn't really need help on those ones.
Good.
Did you already submit it, Dakota?
No, I haven't submitted. I needed help in it. If I make it office hours, because I do have another Zoom, if I make it off, can you make another office hour later on today? Or not today?
I don't have any today, but on Thursday I do. So tomorrow,
Okay.
you just use the Calendly link. Yeah, and you can book it then for Thursday.
Okay.
Okay. Sounds good then, Dakota. I'll see you tomorrow.
Okay, thank you.
Okay, you're welcome. Bye.